All right, so we have made it to the final week of material for the course. Saved multiple regression for last, and there is actually a lot to multiple regression. Certainly, if you were to take a graduate stats course, you would go more in depth into multiple regression, especially the assumptions underlying multiple regression. But here, for me, the most important thing for you guys is that you can run a multiple regression and you can evaluate to some extent whether your X's that you've chosen are good predictors or not. All right. So we are going to focus on being able to get an equation and then being able to evaluate whether that equation is worthwhile to us or not. All right, I think what you're going to find in the 3 problems in the classwork is that this is really easy. When you get to the final exam, to the final problem on the final exam, which is multiple regression, it's going to look exactly like it does here in the classwork, as well as the homework and as well as the quiz. All right, and I think you guys are going to be pretty confident when you get to this problem. All right, so let's look at number 1. And again, what do you want open? You want the multiple regression classwork Word document open, and you want the multiple regression classwork mini-tab file open that begins with income, value, education, age, mortgage, and gender. All right, so let's work through these problems. The production manager of High Point Sofa and Chair, a large furniture manufacturer located in North Carolina, is studying the job performance ratings of a sample of 15 electrical repairmen employed by the company. An aptitude test is required by human resources to become an electrical repairman. The production manager was able to get the score for each repairman in the sample. In addition, he determined which of the repairmen were union members, code equals 1, and which were not, code equals 0. All right, so we've got our sample information. First question, use backward elimination and a 0.05 level of significance to determine which variables significantly predict job performance ratings. Be sure you write your final equation as a single equation and not as 2 equations. All right, so what do we have here? Let's look at our mini-tab file. I'm going to pull our data up here a little bit. And here in C8 through C11, we have the data that pertains to this problem. So we have the worker, all right, the named worker, their job performance rating, their aptitude level, and then whether or not they're in a union. And so we want to see if aptitude and union predict the job performance rating. All right, so we're going to go into regression, multiple regression. All right, again, our response is the job performance rating. All right, and if there's anything difficult to multiple regression, here it is. You have to decide what is a continuous predictor, meaning numerical or quantitative, and what is categorical, which means qualitative. All right, so I'm going to cancel out of this 1 second. Here, aptitude, this is like a test score, so this is clearly quantitative or continuous. And then union is coded as 0, 1, meaning 0 not in a union, 1 in a union. That's qualitative. And so that would be categorical. So we go into multiple regression. Performance is our Y. Our continuous is aptitude. Our categorical is union. Okay? And again, I give you some hints in the homework about being on the lookout for categorical, but on the quiz and on the final exam, I do not, okay? You're going to have your eyes open, looking at your data, determining what's categorical and what's not. All right, so we've got our data in our input screen here, and then we want to go under stepwise, and we want to choose backward elimination, and we want to set our alpha to 0.05. All right, so this is all there is to multiple regression. Putting in your data and then selecting backward elimination under stepwise and setting that alpha to what I tell you, which here is 0.05. We say okay. All right, so let's just go through this. All right, so Minitab gives you the regression equation as 2 equations when we have a categorical variable like we do here with union. All right, I do not allow you to write your equation that way. I want you to write it as a single equation, okay? So what this is saying is that when union is 0, we have this equation right here, the base equation. But when union equals 1, notice the y-intercept goes up. The question is, how much does the y-intercept go up? And the answer is, let's go down here, all right, to union in our model selection details. The amount it goes up is the coefficient on union. All right, so really, when you write your multiple regression equation, I recommend that you use the coefficients from your final step. And I say final step because we're going to see examples where there's multiple steps to the backward elimination. It just so happens for this first problem, both aptitude and union are significant, and so there's only one step to the multiple regression. All right, so let me show you how I'm going to type this equation. All right, so I'm going to start with my y. I can either say y or performance equals, and I'm going to get my coefficient, my constant coefficient. All right, so I look there and I see that it's 29.28 plus my coefficient on aptitude. So I say the 5.222 and then times aptitude, or you could say x1, but I prefer actually you to say aptitude. It makes a little bit more sense to us. Then plus our coefficient on union, which is 22.1351 times union. All right, and that would be how I accept your final multiple regression equation. Okay? All right, using the results of your multiple regression, interpret the adjusted multiple coefficient of determination. All right, so remember from the lecture that when it comes to multiple regression, we do not necessarily want to interpret r squared, this 53.30%, because it continues to go up the more variables we add to the problem, all right, which isn't necessarily good because we could be adding insignificant variables. What we want to do is actually interpret the adjusted r squared, which is adjusted for the number of x's we have in the model. All right, and so what we would want to say here is that 45.52% of the total variation in job performance rating is explained by, all right, and we don't want to say by the x's, because what are the x's? We don't want to say by the model because we want to define our model. So you want to name your x's that are in the model. So job performance rating is explained by aptitude and union membership. Okay? All right, let's go to the second problem. All right, a real estate developer wishes to study the relationship between the size of a home a client will purchase in square feet and other variables. Possible independent variables include the family income, family size, whether there's a senior adult parent living with the family, 1 for yes, 0 for no, and the total year's education beyond high school for the husband and wife. All right, so let's go over to Minitab. All right, and this information, all right, is in C13 through C18. All right, so we have our family column denoting the family. All right, the square foot of the house. All right, the family income. All right, and that is an annual income in thousands of dollars. So really that's $60,800. The family size, whether or not a senior is living in the house, and the number of years beyond high school for the husband and wife. All right? All right, so we want to run, let's see, part A, use backward elimination and a 0.05 level of significance to determine which variables significantly predict size of the home to be purchased. All right, be sure to write your final equation as a single equation and not as two equations. All right, so we want to go into multiple regression. All right, and we're interested in C13 through C18. Square foot is the Y, so the size of the house is the Y. And what's our continuous predictor and what's our categorical predictor? So in looking at C15 through C18, do you see a variable that would be categorical? All right, in other words, it's words or it's coded 01 or 012, something like that. And hopefully you're saying, yes, C17, senior status, would be a categorical variable. All right, so we put income in for continuous, size in for continuous, education in for continuous, and we put senior in for categorical. Okay? Under stepwise, we choose backward elimination, and we choose an alpha of 0.05, and we say okay. All right, so here is a multiple regression where the backward elimination process goes through 4 steps. All right, let's take a look at what happens here. All right, here's step 1. All right, let's look at these p-values. Aha, do you see where senior is 0.7186? That's the largest insignificant p-value. So senior is removed and we move on to step 2. Let's look at our p-values in step 2 and we see that education has 0.3913. The largest insignificant p-value, so education is removed and we go over to step 3. All right, and we look at our p-values and we see that income is 0.0586, which is again insignificant because it's bigger than 0.05. So income is removed and we are left with size. All right, and so our final regression equation is actually a simple regression. All right, and it is just square foot equals 1271.6 plus 540.69 size. All right, so in other words, what significantly predicts the size of the house is the size of the family, and that should definitely make sense to you, all right, because the larger your family, the larger the house you need. All right, now in part B, using the results of your multiple regression, interpret the adjusted multiple coefficient of determination. All right, so we're looking for the adjusted R-squared. All right, so here's our summary statistics. All right, here's the adjusted R-squared, 84.42% for step 1, step 2, step 3, and then finally we get to our final adjusted R-squared of 80.22%. All right, so we come over here and we say 80.22% of the total variation in size of the house is determined by size of the family. All right. Let's take a look at our last question here. The Bank of New England is a large financial institution serving the New England states as well as New York and New Jersey. The mortgage department of the Bank of New England is studying data from recent loans. Of particular interest is how such factors as the value of the home being purchased, education level of the head of household, all right, and that's defined as number of years beginning with first grade, age of the head of household, current monthly mortgage payment in dollars, and gender of the head of household relate to the family income. The mortgage department would like to know whether these variables are effective predictors of family income. All right, so again, part A here, we want to use backward elimination and a 0.05 level of significance to determine which variables significantly predict family income. Be sure you write your final equation as a single equation and not as 2 equations. All right, so we're going to go scroll over in Minitab to C1 through C6. Okay, so let's take a look at our data before we just jump into multiple regression. Family income is what we want to predict, so that would be our Y, or response variable. We're going to use C2 through C6 as our X's. Now, when we look at C2 through C6, is there anything that stands out to you as something that would be a categorical variable? And I hope you're thinking, yes, gender. All right, gender is coded as 0, 1. All right, 0 is male, 1 is female. Oh, sorry, male is 1 and female is 0. All right, and so gender there would be categorical. All right, so we go into multiple regression, and income is our Y. Value, education, age, and mortgage are all X's that are continuous. And then for categorical, we put in gender. We need to go under stepwise and choose backward elimination and change our alpha to 0.05 and say OK. All right, so here is the mini-tab final equation. All right, but remember, since gender is significant, they give us 2 equations, which I don't let you do. All right, and so let's take a look at our actual backward elimination output. All right, so we have step 1, and it looks like mortgage had the largest p-value of 0.7758. So mortgage is removed, backward elimination runs again, and age is 0.1271, the biggest p-value, so age is removed. And then we have the third and final step where everything is significant. All right, so our single final regression equation is going to include these coefficients under step 3. All right, so let's come over here. All right, so we have income equals our y-intercept 74.6 plus 0.06366 on value plus 1.0070 on education plus 1.7764 on gender. All right, so that would be our final equation written as a single equation. And if you'll notice, we'll take a look at this coefficient on gender of 1.77640. That is the difference in the y-intercept in these 2 equations. Okay, because if we take a look at this equation here, when gender's 0, this number falls off. It's not there. So we get this top equation that Minitab gives us. If gender is 1, then we add this 1.7764 to our y-intercept, which gives us the 76.376. The 2 equations are synonymous. I just want you to be able to write it as a single equation because that's typically what we do from an analyst standpoint. All right, last question. Using the results of your multiple regression, interpret the adjusted multiple coefficient of determination. All right, so we take a look at our adjusted R squared and we see from step 1 to step 2 to step 3, and this step 3 is our final adjusted R squared, 67.55%. And so we're going to say 67.55% of the total variation in income is explained by what is left in the in our problem here. So we have is explained by value of the home. All right. What else? Education level of the head of household and gender of the head of household. All right, so that would be our interpretation of the adjusted R squared. All right, so hopefully you're feeling confident about this stuff. You're thinking it's pretty easy. You're definitely ready for the homework. And if you have any questions, just reach out to me.